All right, evening, everybody. Welcome. I hope you can all hear me. I'll quickly go through the concepts, a lot of the concepts that you people need for the solutions. Okay, so I'm going to do tutorial solutions, and then after that, I'll go and show you the 4 sections that you must know for your lecture slides for this topic of TRIG. Okay, simple topic, so we'll be fine in no time, hopefully. I hope you can all see my screen. Give me a second. I want to be able to check if you can all see my screen. So I want to be able to check. Can you all hear me and can you all see my screen in the chat? Please say yes if you can hear me and if you can see my screen. If you can see it clearly, or if there's an adjustment I need to make. If I do this, can you see? Can you see my screen? Is it visible? Guys? Please confirm in the chat if you can see my screen. Are you able to see the questions, and are you able to see the place where I'll be writing my solutions? Maybe let me do this. Instead of this, let me open this one. Just give me 1 second. I'm going to have a blackboard so that you're able to see my screen. Okay. What should I start with, tutorial or slides? Which solutions do you want to see first, from the tutorial or from the slides? The examples from the slides or the questions from the tutorials? Because the slides also has questions, like your lecture slides, which we also need to talk about. Okay, so we'll start with the tutorial solutions. Right. I think when it's like this, you'll be able to see. So I'm going to do this and zoom in. Right. Let's just kill this. In no time, we should be able to finish all the tutorial solutions, okay? No time at all. So this is chapter 1. This is chapter 1. Which is TRIG. I don't want to waste a lot of time, so I'm going to teach you some concepts that we're going to use, and then we just solve the solution. We just put the solutions, we move on. Right. Anyway, question 1, what do I use? So for question 1, what you just need to know is, remember we use dimensional analysis, okay? Dimensional analysis means you're going to be using the very same fraction for everything. If you're converting from degrees to radians, radians to degrees, you use the very same fraction, but you just spin it upside down. And the fraction you use to convert from radians to degrees or degrees to radians comes from the relationship between the two of them. So if you know the relationship, you should know that pi rad is equal to 180 degrees. If you know this relationship, then you have everything you need. Because what we're going to do is, let's start with question A. You'll be asked, please convert 75 degrees to radians. You are going to use this relationship, and you're going to have it as a fraction. Pi and 180. One will be at the top, one will be at the bottom. The one you put at the bottom is the one that you have. So here we have degrees, so that means I'm going to multiply by, degrees will be at the bottom, and the rads will be at the top, because I want rads, okay? And this is going to be, I can change it to be 75 over 180, okay? These are degrees. Then I say pi rad, okay? Pi rad. So I'm just going to reduce it to its lowest terms. So it's going to be 75 divided by 180. Then I'll press this button, second function. Then I press the button which says AB over C, okay? This is to convert to an improper fraction. So I'll say second function a b over c, I get 5 over 12 pi. So this is going to be 5 over 12 pi rad. And you're done, okay? You do it for everything. You do it for everything. You'll be just multiplying by this very same thing. Okay, it's the relationship between the two, and the one that you'll be the one that you have is the one you put in the denominator. Let me do one more, then go to the next one. I'll do part 4, which is negative 45 degrees. Negative 45 degrees, same thing, okay, times pi rad over 180 degrees, because that's the relationship. That's the relationship. So what else can I use? So here I'm just going to have negative 45 degrees over 180 degrees, then pi rad here. Then you just reduce to its lowest term. It's going to be negative of, let me punch again, 45 divided by 180. I get an answer. I say second function a b over c, that button. I'll get negative 1 over 4 pi rad, okay? Negative 1 over 4 pi rad. So that's going to be a solution. Anyway, that's fine. Now let's do part B. What if we were going from radians to degrees? Does it change? No, it's the very same fraction because it comes from their relationship that pi rad is equal to 180 degrees. So the one we have is just going to be the one which goes in the denominator. That's dimensional analysis. So easy, right? So you'd say, okay, I have, let me make this smaller. Give me a second. Okay, so now B. I want to remove, so it's B now. We have 2 over 5 pi rad. Well, we multiply by the very same fraction because that's the relationship. You want to go from degrees to rad or rad to degrees. You use the relationship between the two of them. So it's going to be, I have rad, so this is pi rad. I have rad, so I'm going to put rad in the denominator this time. So pi rad, my friend, you're going in the denominator, so it's going to cancel, obviously. And you're going to have 180 degrees at the top. So it's going to be, at the end, 2 times 180. So it's going to be 2 times 180 degrees. Because 180 degrees at the end will multiply the top, which is 2. So it'll be 2 times 180 divided by 5. You can say that. What answer are you going to get? That will be your answer in degrees. 2 times 180, then divided by 5. That's 72 degrees. So 2 over 5, whatever, is 72 degrees. Simple fixture. I'll do one more for this one. It's the fraction that matters. If you know this relationship, you're fine. Pi rad is 180 degrees. You make it a fraction, you just convert. So in here, to be part C now. Part B. This was BI. Let's put part B1. Let's put part B4. Negative 1 over 3 pi rad. Okay, who cares what it is, man? It's the same thing. So in the denominator, pi rad. At the top, 180 degrees. So this is going to be pi rad, and pi rad will cancel. I'll have negative 1 times 180 divided by 3, okay? Because 3 is going to be in the denominator. So 180 will multiply the top, eh? It will be negative 60 degrees. And you're done. That's your solution. Simple fixture. You go on to the next one. Number 2 now. Okay? Now, here's the thing. So you want to find the 6th trig. You want to, when anything they are saying here, let's read the question. We don't read the whole passage. Obviously, we know that. I've taught that to you guys many times. You look for keywords. 6 trig ratios. Let's talk about them. Okay, number 2. Let's talk about number 2. Question 2. 6 trig ratios. What are they? What are the 6 trig ratios? The 6 trig ratios are, we have, first of all, let's talk about the 6 trig functions. You have sine theta, cos theta, you have tan theta, you have sec theta, you have cos sec theta, or we can say cot theta and cosec theta. Cos sec theta. You see them when we differentiate towards the end of the semester, right? Now, anyway, these are the 6 trig functions, so we want them as ratios now. Well, if the moment they say the word ratio, it's SOHCAHTOA, obviously. So the moment they say the word ratio, it's SOHCAHTOA. So we have a triangle, which is like this. You people need to know that it's like converting from, we did it in Physics 101, from Cartesian to polar. This is the angle theta. You have a right angle. Then you want to find where a certain point P is, right? You want to find a certain point P. We can use theta and R. R is going to be the length from the origin straight to theta. Or we can have X and Y. You tell us how much you move in the X, Then you tell us how much you moved in the y. Here's the y value. So P, we have xy. Now, the thing of it is, this x and this y, these values, yeah? This x is, we can say that, what is this? Why is it delaying me? X is, we can say x is the length because it's from 0 to this point, which is also point x, whatever you say, man. So x is the length and y is the length because it's from 0 to this point, code y. Yeah. So anyway, when you want to look at SOHCAHTOA, because you use this is a right angle triangle. So obviously you are going to use SOHCAHTOA to know the ratios. Okay, I don't want to explain this because you can just remember them. But they come from SOHCAHTOA. I'll just show you where they come from, then I'll teach you what to remember. So, let's label the sides. If we were to use SOHCAHTOA, for you to use SOHCAHTOA, you need to know who is opposite, who is adjacent, who is whatever. So you'd say opposite the angle, this side is the opposite side, okay? Then you go opposite the corner here, right angle, this is going to be hypotenuse. So opposite the angle is called opposite. Opposite the corner for right angle is called hypotenuse. Then the third side is called adjacent, right? The third side is called adjacent. So now you can already do what you need because you would now say, what is sine theta? Sine theta, you would use this, So sine theta is opposite over hypotenuse. What is the opposite here? Y over. What is the hypotenuse? R. Okay? So this is what you are actually going to remember. That sine theta is y over r. Then you can say cos theta. It's from car. All these things came from SOHCAHTOA, man. Cos theta is car. It's adjacent over hypotenuse. What is adjacent? X over. What is hypotenuse? R. Okay? This is going to be the cos theta. Then you have tan theta for TOA. What is tan theta, man? Tan theta is opposite over adjacent. So what is the opposite? Y. And what is the adjacent? X. So it is y over x. Then we can, all the other ones, you can know them from here. So in actual fact, what we can say is the simple fixture for people who want to answer this. The moment you see anything that says 6 trig ratios, the moment you see anything that says 6 trig ratios, you must remember these ones. Remember that sine theta is y over r. This one should be remembered. Remember that cos theta is equal to x over r. This one should be remembered. So this is where you are. This is the work that you're going to do to remember these ones. Sine theta is y over r. Cos theta is y over r. You should also remember that tan theta is y over x. You must remember that, okay? Can you see that? Tan theta is y over x. Then once you have it, you can also now know that, okay, so I have these guys called sec theta. Sec theta is 1 over cos theta. So that'll be just all I need. And cosec theta, you'd say cosec is 1 over cos. No, you're lying to yourself. Cosec is actually 1 over sine. So cosec theta is actually 1 over sine theta. And then lastly, cot theta is 1 over tan theta. So if I can find the first 3, these last 3, I can find them. If I can find sine, cos, and tan, these other 3 I can find. Now, what you must know is that there is going to be the first thing which you always find is r, the square root of x squared plus y squared, okay? You should know this. This is the other formula. So the most important formulas are 1, then this one is 2, then this one is 3, then this one is 4, and you are done. No r, no sine theta, no cos theta, no tan theta. Then you are going to rest, okay? You can say, hey, bring me some water. I need to relax now, man. I need to relax. Can you see this? These are anything you see. I don't care what the question says. The question can say, find all 6 trig ratios, or it can give you 1, then say, find the other 5. You should just have these formulas down. Then you use them appropriately, and you'll find your solution. Are we together? So now let's start with this one. Let's start with the first one. Let's just find these simple fixtures. So number 1. Number 2i. We have been told that pxy is equal to 2 root 3. 2 root 3. So basically, I have x, I have y. So you can come here and say x is equal to 2, y is equal to root 3. But I don't have r. I'm going to need r to find the other ones. So I should now say r is equal to the square root of x squared plus y squared, which is going to be equal to the square root of 2 squared plus y root 3 all squared, which is going to be the square root of 2 squared is 4 plus root 3 all squared. The root 3 will go, so it will be 3, which is going to be root 7. Can you see that? Hello? So this is going to be the first one, right? Now, what are you going to do here? We have found this because it's 4 plus 3. Then you got 7, so it's root 7. Now you can find the 6. They said, what do they want you to find? Find the values of the 6 in each of the following. Anyway, let's start finding. We are done. Sine theta is y over r. So you can say sine theta. You should know the formula. Actually, you know the formula. I gave you, right? You have the formula, right? So use it, man. Because you have x, you have y, you have r. So why don't you use it? Why not? Tell me why. Tell me why you are not going to use it. Besides not wanting max. Something so easy. So you know that sine theta is y over r. That's the job. You need to remember r, how to find it. Then you need to remember how to find sine theta, cos theta, tan theta. Basically. So either way now, I would say my sine theta will be, what is my y? My y is root 3 over what is my r? Root 7. So it's going to be like this. Root 3 over root 7. Okay? That's going to be your sine theta. Then you can say, what is my cos theta? Cos theta is equal to x over r, which is going to be, what is my cos theta? My cos theta will be, what is my x? 2 over r root 7. So it's going to be 2 over root 7. This is going to be your cos theta. Then the third one, what is my tan theta? Tan theta is y over x, which is going to be, what is my y? Our y is root 3 over x 2. So it's going to be root 3 over 2. Stuff like that. So it keeps going like that. Can you understand? Isn't this simple? Then now, once you have these 3, you can find the other 3. Oh man, come on. You can find the other 3 because you now say, okay, that means part 4, for me to find sec theta, it is 1 over cos theta, which is going to be 1 over, we can just, if it's a fraction, you flip it upside down. So cos theta is 2 over root 7. So that means sec theta is going to be root 7 over 2. You flip it upside down. That is going to be your sec theta. Then you say part 5, I now need cosec theta, which is 1 over sine theta. So if sine theta is a fraction, I'm just going to spin it upside down. That's what it means to say 1 over something. Root 3 over root 7, you just flip it upside down. So it's going to be root 7 over root 3. Then part 6, the sixth one is cot theta, which is just 1 over tan theta. 1 over tan theta, which is, if tan theta is a fraction, I'll spin it upside down. If it's a number, I'll just say 1 over that number. So here it's a fraction, root 3 over 2. So I'm going to flip it upside down. It will be now 2 over root 3. You can find the rest, okay? The job is now yours. I've done this one for you. You can do the other ones, okay? Because you've been given x, you've been given y. Find r first. Find r, then just use these ones, man. Sine, cos, tan. Then you can find the other ones. Sine, y over r, x over r, y over x. Come on. You got to remember them. You have to remember them if you're serious about getting marks, eh? You can't tell me you can forget 4 formulas. Come on now. No, that's not going to happen. It's illegal. I'm not going to finish it. Can I go to the next one? Is there anyone who has a question on number 2 still? Hey, in the chat. Is there anyone who has a question on number 2? Any question on number 2 still? Yes, what is the question? You can ask the question. Should I do another one or what? If I should do another one, you should say do another one or whatever. Is there anyone who has a problem on number 2 still? Hello? Hello? Anyone with a question? Why is the chat quiet now? Okay, I'm going to move on. All right, so now, C denote the circle of radius 2, centered at the origin. Let's do number 3i. Let's see what is going on there. Circle of radius 2. If the terminal side of an arc length pi, starting at the point 2, 0, what is the length in degrees between the terminal side and the positive x-axis? Okay, so let's talk about this one, okay? Let's talk about this one. What is it that they are giving us? What is it that they're giving us here when they're saying that the terminal side of the arc, what? The moment you say the arc, the moment they say anything to do with arc, let me just show you. Arc is from a piece of pizza like this, you understand? Anything to do with arc is something like this, from a piece of pizza like this. And arc will be the outside of your piece of pizza. Let me increase the size. Anytime they say arc is from a piece of pizza, so this is going to be the arc, eh? This is going to be the arc. And then this is going to be the radius. And then this is going to be the theta. Okay? So here, what do they want? They want, what is the angle? They want the angle. So the radius, they've told us the radius, right? What did they say? They said the radius is 2. So R is 2. Now, let me tell you something about it. So this arc is the outside. It's this outside part of it, okay? The outside part. So you have R, and then the arc is called S. The length of the arc is going to be called S, okay? The length of this arc is going to be told. So if we are going to say here, we're going to write it like this. This length S, the formula says S is equal to R theta. This is the formula that is used to find it. S is equal to R theta. So if you see here, they said, let's see, denote the circle of radius R at the origin. If a terminal side cuts an arc length of pi, cuts an arc of length pi, so the length of the arc, so here we can say that S is equal to pi, R is equal to 2, then they want us to find theta. Theta is equal to question mark. So you're just going to say S is equal to R theta. Then now you're going to say S over R is going to be equal to theta. What is my S? My S is pi over 2. This is going to be theta. Done. So this is a bit of a joke. And they want it in degrees. What is the angle in degrees? They want it in degrees. Because they told us the length of the arc, then they told us everything. So here they told us, just deal with the information. They told you that arc length is pi. And they told you that the radius is 2. So anyway, you can find your theta. And you found your theta to be pi over 2. So now you can say, anyway, this is pi over 2 rad, obviously. So you can say pi over 2 rad. We want it in degrees. We know the relationship. Pi over 2 rad. Remember that pi rad is equal to 180 degrees. This is the relationship, and we're going to make it a fraction. Yeah, so it's 90 degrees. People know that. So it's going to be times pi in the denominator. Well done, whoever says that. Then 180 degrees at the top. So it's going to be pi rad cancel. This becomes 1. This becomes 1. So it's going to be 1 times 180 degrees divided by 2, which is going to be 90 degrees. So this is going to be 90 degrees. And this is the angle. Let's go to part number 2. Okay. Reading, it's very long. This whole story, terminal side, blah, 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 makes an angle 75 degrees with a positive. What is the angle? Okay, so let's now write here. The terminal side in problem 1. So what are they trying to say here? Why did they say terminal side in problem 1? They are trying to say, use the same radius as problem 1. Now you have theta and you have radius. Find S, the arc length, because they're saying, what is the length of the arc? So we know that the equation is S is equal to R theta. The length of the arc is R theta. Let me tell you something. Theta should not be in degrees. We don't do calculations of things like arc length and all these other things with a theta in degrees. That's why here we were finding theta in rad. Theta is going to be pi over 2 rad. It's always radians when you're doing the calculation. So that is going to be where you're going to be caught. So first of all, you're going to say 75 degrees. You know the relationship that pi rad is equal to 180 degrees. So you have to convert it to radians first, then you can use it in the formula. So it's going to be times. Degrees goes in the denominator, 180 degrees. And at the top, we put pi rad. That's something like this. So what are we going to do? We would say 75 degrees over 180 degrees by pi rad. Then we would simplify. I think we did it before. I've forgotten. 75 divided by 180, you get something. Second function, a, b, it's 5 over 12, okay? Remember, when you divide, say second function, then press the button which says a, b over c, so that you can have everything as a fraction. Because we only work with fractions here, okay? We are no longer in primary school. 5 over 12 pi rad. Okay, thank you for that. So now we're just going to say S is equal to R theta, which is going to be equal to, what is the R? 2 times, because they said it's the same as the previous question, times 5 over 12 pi. Okay, because I'm gonna I don't have to put the word rad. So what am I gonna get now? 10 over 12 times pi. So it's gonna be 10. You can say 2 by the way, 2 times 5 times pi. I get an answer. Then I say divided by 12. I get an answer. This is going to be 2.62. Okay. Going to be 2.62. Whatever the units. 2.62. These are going to be the units. And you're done. You're going to be done. We move on. Next question. Number 4. Give me a second. I need to drink water. Something is in my throat. Whew. Lucky me, I managed to remove. So, anyway, sorry, excuse me. Find the positive value. Right, guys, let me just say this. If you're asked to find, this is question number 4. We are done with this, so we did the arc length, blah, 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 we are done with it. Now we are saying, how do you find a value between, if they say find a value between 0 and 2 pi, and if they say to you, find a value between 0 degrees and 360, okay? Between 0 and 360. By the way, 0 and 2 pi and 0 and 360 is the same thing. So here's the thing. What you're going to do is, if you get a value which is very, very big, which is just so big, you are going to know that angles repeat after 360 degrees. We know that by 360 degrees, you are back where you started. Okay, when you go 360 degrees, you'll be already back where you started. So what we are going to do is, we are going to be removing 360 or adding 360 till the angle is between 0 and 360. If it's in radians, we are going to be removing 2 pi rads, because if we remove 2 pi rads, we have not changed anything. We'll be back somewhere. We keep removing 2 pi rad until we get an angle that is between 0 and 2 pi. So, hey, don't disappoint me. Don't disappoint me. This is a simple thing. I said, when you are doing these conversions, listen, you should always add 2 pi rads until it is between 0 and 2 pi. That's if it was negative. Again, if it was negative and it is in degrees, add 360 until you get a value which is between 0 and 360. If it is very big, subtract 2 pi rad. That is if it is in radians. You'll be subtracting a complete revolution until you get an answer which is in the range you want. If it's in degrees, subtract 360. You'll be going back where you want, but you'll be reducing the value so you get an answer which is between 0 and 360. So this is just so easy, right? Let's start with the first one. The first one, you have 15 over 4 pi rad. This is absolutely meaningless to us. Absolutely meaningless. So what we have to do is we have to remove 2 pi rads. This guy, a complete revolution. So now what you're going to need to do, here is where it becomes nice. If your value had over 4, you must subtract a 2 pi rad, which is over 4. So I want to subtract, so I can say minus 2 pi. Let me do it step by step so that people don't get confused. So anyway, I get this huge value. I say minus 2 pi rad. Okay, now 2 pi rad, when you are subtracting 2 pi rad, you must know that this one was over 4. So to be fair, we should put 2 pi over 4 as well. And to put it over 4, you multiply it by 4, then put it over 4. So if we multiply it by 4, we will get 8 pi. So this is the same as 8 pi over 4. It's just the same as 2 pi. So we want 2 pi. Remember, you put your 2 pi in pencil. I want 2 pi. But I need the version which is over 4. So I multiply it by 4. I'll get 8 over 4. Pi rad. And I'm subtracting because this one is big. I'm trying to bring it back by 2 pi until I get a value which is between 0 and 2 pi. If you're not understanding, hey, bring it back. Remove 2 pi from it to bring it back. And when you're removing 2 pi, remove a version of 2 pi which is the same as this one. So this is over 4. So we are going to subtract 2 pi, but we subtract a version of 2 pi which is over 4. And a version of 2 pi which is over 4 is, you first multiply it by 4, you get 8 pi. So it will be 8 pi over 4 is the same as 2 pi. And the reason we are doing that is it will help us. So what are you going to get? 15 minus 8, you get 7 over 4. Okay, by the way, you still have a cheat code. If you don't want to do this, you can use the calculator. The calculator will not let you down. Okay, the calculator won't let you down. Let me show you. Let me just do this. 15 minus, because both of them are over 4. 15 minus 8, you get 7 over 4. So this is now 7 over 4 pi rad. Okay? 7 over 4. Is it bigger than 2 pi? No, it's not bigger than 2 pi because 2 pi is 8 over 4. So now you have a value which is between 0 and 2 pi. Are we understanding? So the answer is 7 pi over 4. This is just so cheap. You know what I mean? I don't know if you get it. If you want to do another cheat code, you'd say, okay, I have 15 over 4 pi. They said, hey, find the exact value. So what I'm going to do, I'll subtract 2 pi. And I'll see what answer I'm going to get. So you, in the calculator, ignore the pi. Okay, ignore the pi. In the calculator, you'd say 15 over 4 minus 2. Tell me what you're going to get. Let's punch together. 15, open bracket, okay? Open bracket, 15 over 4, close, minus 2. I get an answer. Then I say second function, A, B over C. Second function. Then I press the button which says A, B over C. I'll get 7 over 4. So it'll be 7 over 4. What? Pi. 7 over 4 pi. Don't forget pi rad, because everything was pi rad. We subtracted 2 pi rad and you're done. So that's what you're going to do. Your calculator can bail you out. Anyway, let's go to the second one. Negative 850 degrees. My friend, you are negative. I'm going to actually have to add 360 degrees. I know that I always, if it's degrees, I will add 360 or subtract 360. So until I get a value which makes sense. This doesn't make sense. So I'm going to say negative 850 plus 360, okay? I'll say plus 360. What am I going to say? I'll say plus 360 degrees. I'll get negative 490 degrees. I'm still not happy. I want an answer which is between 0 and 360. So I'll now say negative 490 degrees plus 360 degrees again, okay? So I'll say this one plus 360. I'll get negative 130. Can you see? I'll get negative 130. Do I want negative 130? For what? It's not between 0 and 360. It's meaningless. So you're going to say negative 130 degrees plus 360 degrees. What are you now going to get? We want an answer between 0 and 360. So I'll say that answer plus 360. I'll get 230. Well done. So that's your value. So your answer is actually 230 degrees. Okay? So it is 230 degrees. That's your answer. You do it for the same thing for here. Negative 5 over 3 pi rad. This is meaningless to me. It's not between 0 and 2 pi. So I'm going to change him by adding 2 pi. I have to add 2 pi because he's negative. So I'm going to add 2 pi rad to this guy. So in the calculator, ignore the pi. You're going to say open bracket, negative 5 over 3, close bracket, plus 2. Don't put pi. Okay? You don't put pi. You get 1 over 3. But when you get 1 over 3, put back the pi. 1 over 3 pi rad. There you go. So that's going to be a solution. And 1 over 3 pi rad is the same as saying pi over 3 rad. Okay? It's like that. Then we say number 4, 600 degrees Celsius. This is just so big and meaningless to us. So we are going to remove 360 degrees until we get a value between 0 and 360. So we say 600 minus 360. We are going to get 240 degrees. And that is going, don't put degrees Celsius, by the way. This is not temperature. So this is 240 between 0 and 360? Yes, so well done. Okay, you have found the positive value in the interval, blah, blah, blah. Okay, you hear me? Don't lose marks for this. Anyway, how many questions are there? Do I want to finish this? Pinky, pinky, ponky. Father had a donkey. Donkey died, and father. Can I ask you a question? Who is writing a quiz this week? Is there a quiz this week? It's next week, right? The quiz is next week, right? When are you writing your maths quizzes for this? When are you writing the maths quiz? Josh, anyone in the chat, when are you writing? When are you writing the quiz? Next week, okay. So it's fine. This is enough. I've done 4 questions. Tomorrow I do the other 4. Number 5, number 6, number 7, number 8. All questions are just so simple. And I'll need to do the questions from your slide. So this is round 1. We meet again tomorrow, okay? Goodbye. Sleep well.